Hello, everyone. Welcome to the panel about quantum computing and Kubernetes. We've talked a lot about how Kubernetes is complicated. Now we make it even more complicated by throwing quantum computing into the mix. And so most of us have heard the term quantum computing mostly as a theoretical pursuit. We've not really seen what the real-world applications around it are and what does it really mean to run quantum workloads on Kubernetes, and how we can make the Kubernetes and cloud-native ecosystem quantum safe. We've talked a lot about AI. Then why are we even talking about quantum now? Because AI is already so complicated. Because if we don't start talking about quantum now, we're going to run into trouble later on. So we need to make progress while we still have time. So since we're short on time, we've just got 30 minutes, and I'll try to leave some time for questions. Let's dive right into it. So we've got a wonderful set of panelists here. Why don't you all go and introduce yourselves?
So my name is Natalie Fisher. I work for VMware by Broadcom with Nikhita on the Kubernetes area stack. So I work as a product manager there.
Hi there, everyone. I'm Nigel Jones. I work for IBM Research. So I'm involved in post-quantum cryptography and quantum and our services there, and now doing some work with AI. So it's an interesting intersection to talk about today.
Yeah, and I'm Tomas Gustavsson. I'm Chief PKI Officer at Keyfactor. I've been working with cybersecurity and public key infrastructure, PKI, and open source for the past 30 years.
Hi, I'm Ricardo. I lead the platforms infrastructure team at CERN. I'm responsible for the teams doing cloud-native deployments as well as machine learning deployments, and now also starting to look at quantum computing management.
Awesome, thank you. And as Natalie already said, I also work at Broadcom. My name is Nikhita. I'm a principal engineer there. I've been involved in the Kubernetes space for a long time. Now, quantum space interests me, and I thought, why not we talk more about this at KubeCon? So let's get started. We've talked a lot about the AI hype, so I just want to circle back and talk about the quantum hype. When's that going to happen?
So I think we're all learning about quantum computers, and we're still looking for real-world use cases, but these systems are developing rapidly, and we know that at some point, if we take cryptography, for example, you know, that some of the mathematical problems which those are based on could be attacked by quantum computers. But it isn't just hype. There are actually services out there. I work for IBM. We're for quantum services in the cloud. And so it is about then making those available to people so that they can start experimenting and start learning with them.
Yeah, I can say what we are doing at CERN. So at CERN, we have two main initiatives around quantum computing. Actually, there have been people looking at this for a few years now. The first one is CERN helps lead what's called the Open Quantum Institute in Europe. So we have a role there, and this project is more about the governance and the access to this type of technology. We have another effort that's called the Quantum Technology Initiative, which is actually now in phase 2, which means there was a phase 1 before, so it's already progressing. And here it's more about the technology aspects, and not only the development of the algorithms and identifying the use cases where things can match, but also ensuring that we can manage these workloads and deploy them efficiently and in some way cost-effective as well. So yeah, we're quite involved internally.
And working in PKI, post-quantum cryptography is one of the hottest topics since NIST standardized the first quantum-safe algorithms in August last year. So it consumes a lot of our times, and it's a big topic on all kind of industry-focused or cybersecurity-specific focused conferences.
Do you want to go ahead?
So one of the things that kind of got me into this particular space is we were talking about cryptographic agility. So how can you quickly change cryptographic keys? And it sounds like you are also working on something very similar to that. One of the things that has sort of driven the projects that I was working on, because I used to work in research, is the US government had basically made an announcement in 2022 about having to support quantum computing, basically by 2035. And because the field is so nascent, there's so like everyone's kind of saying here, there's a lot that we don't know. There's a lot that's still going on. There's a lot of research that's still occurring. And one of the things that's really important is try to figure out like how can we get there, because we're still pretty far behind. There are companies such as drug companies like Pfizer that are using this to kind of test out molecules. So that's like one of the more practical ways, if you will, of working on it. And then you also have logistic opportunities as well that kind of plays in with AI workloads as well as quantum computing, where they're trying to figure out best ways to identify different routes and ways to get around.
So I think you all raised a really great point, especially around cryptography, that there's a lot of changes that we need to do. So can we like talk a little bit more about that? So say, for example, in this whole cloud native ecosystem, or just Kubernetes to start with, what changes do you think we'll need to bring in?
A lot of almost all security in Kubernetes, be it MTLS or digital signatures, JSON web tokens, code signing, everything relies on asymmetric cryptography. And that is, as Nigel said, the algorithm, RSA, elliptic curve, Diffie-Hellman, those algorithms will be broken when a large enough quantum computer sees the time of light and Shor's algorithms can be run on it. So that's, and of course, everything, not only Kubernetes, but everything in society relies on these algorithms. That means, we have to update things, or what we today think is secure will not be secure anymore.
I think another part of this as well is we need to understand what cryptography we're actually using. So getting a cryptographic inventory. We've talked about SBOMs for bill of materials. There's a standard called CBOMs, which also kind of augments that with information about your cryptography usage. And that needs to be, it's not just about what's in Kubernetes and how we build Kubernetes, but it's also that awareness and that usage, far beyond that. I think understanding what you've got, prioritizing as well. So we hear of this, harvest now, decrypt later. So the idea here is we can capture traffic at the moment, save it, and then come back to it when quantum computers are able to break it. That involves looking at the risk. It's going to be relevant perhaps for your very high value data that has a long lifetime that's still going to be valuable in 5-10 years time. It may not matter for your shorter lived data. So I think understanding what you've got and then working out how you kind of prioritize is really, really important. You won't fix everything at once. And we in the open source community have to help. Things again like the SBOMs and CBOMs may be a small part of that.
Do you already see work happening in any of the projects or anywhere in the community?
So I'm actually a TSC lead for a project that's within something called the PQCA, Post-Quantum Cryptography Association. We have implementations of some of these standard track algorithms like MLDSA, MLChem, and are working towards making sure those are high assurance so that we can start including them in stacks. There's other efforts going around in other projects, OpenSSL, for example, 3.5 I think is coming out soon. So that's going to add support for some of these algorithms, and we'll see that filter up through the stack. So I think for all of the project maintainers working on other components, it's about being aware of what's happening with those dependencies and making that available through your particular projects.
This is not to put you on the spot, but IBM's working on an open source Qiskit SDK, right? So that's pretty available as well for people to kind of look at and play with. But I don't know too much about it. I don't know if you do. That's why I said I don't want to put you on the spot.
So Qiskit is an open source toolkit for developing quantum applications. That it absolutely is out there. It's been there for a while, and people can take a look at it. That itself is open source. Will work with multiple backends. But yeah, I would definitely say if you're interested in quantum computing, lots of companies have education material around there. So I think it is something that is good to start start learning about and understanding why it's different. It's not that quantum computing is going to replace classical computing. It's actually how it augments it, and how some of those little functions that just happen to work well on quantum can be part of our standard business processes.
Yeah, I just wanted to, the one thing that I found interesting was you said, so there are changes that are already being made in certain projects, and that's something that we're going to see up the stack going forward. So from a Kubernetes or just a platform engineer perspective, right? So when I talk about migrating clusters to a quantum safe future, what does that really mean?
I mean, there's a couple of things. One is making sure the infrastructure is modern. So one prerequisite you could say is TLS 1.3. I think in most Kubernetes cases it's probably modern enough, so TLS 1.3 is used, but other legacy organizations have just a huge uplift to move from TLS 1.2 to TLS 1.3, and things like that. When after that is done, you also need to make sure all the components are upgradable easily, right? You can't be stuck with legacy for years by now. You have to be more agile and updatable and keep track. And then it comes into the crypto agility aspects last, right? So projects can't hard code for RSA or EC anymore. It has to be configurable, so it's easy to update, once the development reaches production maturity. So you're not stuck there either. You don't have to redevelop too much of the components. So those are, I think, three key aspects that the community really has to step up to.
I think one point also when we talk about making use of these post-quantum algorithms within our software stacks is sometimes the key sizes may be bigger, right? The packet sizes may be bigger. In many cases, you may be using hybrid schemes where you're combining traditional encryption with, say, elliptic curves together with quantum safe encryption. And again, that can increase resource sizes, and CPU may be especially important with very small sort of transactions or very high volume.
Yeah, and for some applications it won't matter at all, but for some applications it may have huge impact. So we don't know until we start testing. So kind of starting to play around early, I think it's important.
So let's switch gears a little bit. We've talked a lot about security and the cryptographic side of things, but what about running quantum workloads on Kubernetes? What gaps do you see right now, and where are we at?
Okay, I can try that one. So the cryptography is not the main focus where I work for looking at quantum computing. There are clear use cases where we already have workloads that have been seeing benefits from this. So I'll give two examples. One of them is beam calibration. So we have large particle accelerator, we have proton beams going around. Calibrating these beams is actually a very hard task. So people have been looking at quantum algorithms to help out with this, to do this live. They actually validated these algorithms with a live proton beam, which is quite interesting. The second one is a lot of effort around quantum machine learning. So we talked about what's the complication that quantum computing is bringing to the cloud-native area after AI. It's actually very tightly related in some of the workloads. So even things like the Higgs analysis, the Higgs boson, which is a lot of what we do is just analyzing the data coming from the detectors and trying to discover things. There are quantum machine learning algorithms that will help us with this. They do have issues right now because of the problem being the dimensionality of the problem not being adapted to the current hardware we have for quantum computers. And this is where things get interesting, because you can do reduction of the problem using traditional machine learning algorithms, and then do the second step using quantum algorithms. And this is the main challenge we have on the platform side, is that we have to integrate this kind of hybrid scenarios where you have more classical and quantum workloads in the same stack. So this is what we are investigating from a platform perspective, is how we can have these very complex workloads, how to manage them in a hybrid world, which will stay there for quite a while. There are other challenges which are more on the infrastructure side, which is we very likely will not have quantum computers on site anytime soon, so they are remote. So we need to integrate them in much more of a HPC-like way, where you send workloads to the cloud or remote and fetch the results and then integrate with the rest of your analysis, a lot more than the tightly coupled infrastructure you would see on a traditional data center.
I think also, and the other side of that, if you like, from a provider perspective, is that Kubernetes is critical to us when we offer quantum services through the cloud, because the actual computation that happens on the quantum computer is just a small part of that. There's a lot of pre-processing, there's a lot of post-processing that occurs, there's a lot of control that's involved around how you manage these systems, and then there's all the usual kind of boring stuff, right? Whether it's CI/CD process, whether it's login, whether it's authentication, and all of that again is based on Kubernetes. So Kubernetes is a critical part of making this utility available to people.
And I think the parallel with AI is also very good in this case, because when the AI hype started a couple of years ago, there was this notion of what's happening to cloud native, where is AI going? But all of us that were doing cloud native for a long time, there was not a lot of motivation to go and reinvent the whole stack and redo all the tools that we all rely on for several years. There's a strong motivation just to integrate this type of new workloads, maybe adapt the existing systems to accommodate properly, and I think the same will happen for quantum computing as well.
Natalie, do you want to add something?
Oh, no. I was just going to say, they both kind of already said what I was going to say. Basically, I was just going to say the similar thing, whereas in terms of how Kubernetes is currently interacting with quantum computing, and of course with AI workloads right now, it is acting as, of course, the orchestration component aspect of it, but everything right now in that space is hybrid. But I think the thing that Ricardo was kind of mentioning that I thought was really interesting is where it's going to go from here, and what does it mean when it's not hybrid?
So we talked a lot about, you touched base on quantum machine learning and such. So if someone's here interested in the audience about it, what should they do about it? How can they, what's the next step for them if they want to tap in and get
started? Quantum machine learning?
Yeah.
So I think the first step is to actually have a use case that can benefit. Machine learning is actually a pretty good use case for quantum computing. I don't know, if you listen to people talking about quantum computing, is what was mentioned before. A lot of people think this will be the next generation of computing. This is clearly not the case. There will be a hybrid world. So I would say the first step is to really identify a good use case. The second thing is that what was mentioned before, which is there are toolkits that can simulate quantum computers, and this is a really good step to introduce yourself and your tools to this type of workload, like Qiskit is a very good example. The third thing is that quantum computers are real, and you can actually get access to them through even your public cloud providers that you probably already have access. Some of them offer services in their catalog that give you access to quantum computers. I'm not saying it's easy then to start using them. That's why the integration with Kubernetes is interesting. There are challenges. I'm happy to expand a bit on some of them. But you can do it. It's real. It's not coming. It's there. Yeah.
Don't you also? Just discussion here. I mean, I think the quantum algorithms, they work quite differently from what we're used to from classic computing. So isn't there a quite steep learning curve in order to kind of understand the actual utilities for these new machines?
Yeah. Oh, this is luckily not my job where I work. I work on the platform side, but we do have the advantage of being a physics laboratory. So a lot of people understand this technology really, really well, even the theory behind it, and they are pushing the boundaries. This is why CERN has a lead role in things like the Open Quantum Institute and the Quantum Technology Initiative, is that we have the knowledge in-house of how these things can have an impact for us and potentially for other use cases as well.
And I think the other thing in this space as well is as we learn more about these algorithms, more of them are developed, then they themselves become offered as a service that other people can just consume. And so you have a certain financial workload and you look at some optimization problem, you're going to call out to this algorithm. The other thing that then becomes interesting from an AI perspective is your AI model can call tools, your AI model can call these services. So it itself can have access to these quantum-based algorithms, as well as then AI being used to help you develop those algorithms and write your software just like you write your normal software. So I think there's a lot of potential with AI on multiple sides of this.
That makes sense. Just out of curiosity, so who here has played with quantum computers or just has some experience in this area, be it the cryptographic side? Okay. Just 2, 3, 4 maybe, and I get who here is interested, or maybe 5. Who here is interested to get into this space? Okay, that's a bunch. So for folks who are interested, what more can they do? Like, what are the tangible things? For instance, when I was learning more about it, I was like, okay, this is cool, but it looks like something that I cannot take an action upon right now. So for instance, there are some maintainers of projects or people working on certain projects internally in their companies. What should they be doing? What's the next action item for them?
I'll give a first shot. I mean, I think myself, when the post-quantum cryptography came along, I've been working with this a long time. It's fun. It's new things, new algorithms, applied in similar ways, but it's a lot of fun. So you can have a lot of fun with this. But yeah, you have to learn what the new algorithms are, how they work, how you apply them. So there's a lot of things you can study up on them. How will the new hybrid key exchange work in TLS, for example, and then and cryptagility as well. Has been a lot, regardless of which industry you work in, be it financial or government or whatever. Now there's a huge flurry of new white papers coming out, how to apply cryptagility. It just came out a couple of weeks ago, one from NIST, which is a real good, almost educational. What are the things you have to think about when it comes to cryptagility? If you're developing stuff, if you're deploying stuff in your platform, what are different aspects you have to consider? So there's a great lot of good material out there to read up on.
Yeah, I'd echo that. I think there's a lot of material out there, whether it's on the cryptography side or whether it's on the quantum computing side. And I guess one thing for anyone who's new to an area is I mean, I know this is a maintainer on projects, right? It's such a great thing when new people come along and have new ideas or say, why is this so complicated? Or why is this documentation poor? And that's where new contributors, I think, are just so immensely valuable. You think you come along to a new topic area and you don't know a thing, but actually you're bringing that extra insight and then helping to spread the word more broadly. So I think I would encourage people to try and get involved.
I would also add, this is a very new area. I will give an example of how early it is. There are concrete uses, but it's quite early. So, for example, we started procuring for access to quantum computers because there are a few around the world. There is no standard to define how you measure the workloads or how you cost or you do the costing of the workloads. Now, to procure resources when you don't know how to actually define the cost of what you're using is really, really hard. And this is where not only this area needs quantum computing experts and IT experts, it needs all sorts of people. It needs the business people to actually start making something more concrete from these services. It's really funny when you start looking into it how different. Each quantum computer is defining how you submit a workload, how you measure the efficiency, how you can actually ask for access and time. So it's quite early, which makes it really interesting in all sorts of areas. So even if you're not like a quantum expert, there's a lot to contribute to.
So there's a lot of resources, it looks like. So while I was putting together this panel, so I would probably try to keep this as the last question and have some time for audience questions. So while we were putting this panel together, there was one more panelist who was going to join us, Paul from IBM. So when we were discussing about this, we realized that there really isn't a space in the CNCF community where we can, a forum where we can talk about this. So Ricardo, I'm going to put you on the spot. You are in the TOC, the tab. So where is this forum now? What should we do?
Yeah, I think it's good to look. I think there are two areas. One is to look at what we did with AI. There was a lot of demand to have cloud-native infrastructure evolve to accommodate AI. And this needs two parts. One is to do the governance of all these projects and to integrate them in the ecosystem. So I think that role belongs a lot in what we have in the technical oversight committee. Mm-hmm. So we created this AI working group that has a lot of the people doing the work, getting together frequently. They published a white paper that kind of defines the state of the ecosystem and gives some directions of where we should go. The other part is the more technical evolution of the platform. And we learned from AI that Kubernetes actually is extremely flexible in accommodating workloads that are not just managing nodes or containers. It became an orchestrator for a bunch of stuff. And this is the area where we can learn a lot from what we did for AI or HPC, all the new scheduling primitives, all the evolution we did in this part. This is essential to accommodate new things like quantum computing. And the fact that we were successful doing this for AI really gives a lot of optimism that we'll be able to do the same for this new era as well.
Nigel, do you want to talk about the PQC?
Sorry?
The PQC.
The PQC?
Yeah.
So again, as I said, there is some work going on in something called the Post-Quantum Cryptography Association. That's around curating some of the work in this space. It's part of the Linux Foundation. It's not part of CNCF. And I think, our groups at like PQCA and CNCF need to work closer together on this, and also other groups like there's OpenSSF, of course, as well, when we're looking at the code analysis side.
Yeah, we had a workshop on Monday at the Maintainers Summit about what we call the TAG reboot. The TAG is the technical advisory groups in the CNCF, and we propose to have more flexible way of starting initiatives. So I think launching. Whoever is interested in this area, we should push to launch an initiative to start getting people and discussing more closely, to not only have like a panel during KubeCon, but have this going steadily during the year as well.
Yep, so if anyone's interested, please find Ricardo after the session, and maybe we can spin something up. Yep. So to summarize the key takeaways, right, and to simplify it really, I see mainly three takeaways. One is that quantum computing isn't going to replace the classical systems, but in fact, it's going to augment them. The second one, we've talked a lot about cryptography. So there is a huge transition that is coming to quantum-safe cryptography. There's a ton of work that we need to do, and we need to start right away. And like how we talked about AI, Kubernetes is going to play an integral role in quantum workloads, and we need to start looking at filling those gaps and doing all the work behind them. So with that, let's end the panel here, but we'll open up for questions from the audience. There's a microphone with a stand over there if anyone's interested.
So we saw 5 hands raised before, so come forward and ask questions.
Like 5 hands.
Okay, so I guess no questions, so you get some time back. But if anyone's interested, I see a few questions over there. Okay.
Hi, this is mainly for Ricardo, but kind of open to everyone. You mentioned some of the challenges you faced when integrating quantum workloads with Kubernetes. I'd be interested to hear a bit more about these.
Right. So the challenges are still there. I'm not going to claim that we sorted it, but I think the summary is that we have this, the workloads, the quantum workloads integrate with the classical workloads. So we have this hybrid scenario where we need to delegate a part of the analysis or the process to quantum computers, fetch the data back, the results back, and continue. The fact that this infrastructure is not where the rest of the infrastructure is poses a problem on itself. So it's the same issue we discuss constantly in the community about multi-cluster, hybrid deployments. This challenge is even more visible in quantum computers because the interfaces are not necessarily what we expect. And this is where I think if the providers of these quantum computers start offering the APIs that we expect, it benefits a lot everyone. The second one is what I mentioned before, is that when we want to procure or access these quantum computers, the way we define the workloads is very different between the different devices we have access to. There is no standard across for defining units of computation across the different quantum computers. This is also a challenge. And the last one is that a lot of the algorithms are also suited to specific devices. So there's a lot less, because of the lack of standardization, some of the workloads are fitted to a specific type of quantum computer or a specific implementation, which also poses quite a lot of challenges, not only in orchestrating these things, but also making sure we have time available in that specific device. And this is, I don't know, we all have this issue with AI currently with the lack of, the scarcity of GPUs. It's much worse in terms of quantum computers. Like if you have a lot of people interested, there are not a lot of devices available to actually move forward. So yeah, I would say this is what I currently face. I'm sure if you go up the stack, people are facing other challenges as well.
Thank you very much.
Hi, thank you for the panel. That was really great. So in February, Microsoft unveiled their major 101 quantum processing unit. So my question is a little bit more about ethicality, and is there any consideration about ethicality to releasing them to a sort of wider audience before they start, breaking cryptography, on a wider scale? Thank you.
That is a hard question. How do we answer that? The ethics. I guess it's like any service. Go.
Yeah, I mean, security has been having this kind of history a long time, coming with CVEs and exploits and things like that. So probably when it comes to, when finally a cryptographically relevant quantum computer comes along, well, it might not be from an ethical hacking group or an ethical organization, who knows. So hopefully it's going to be very gradually and obvious when it happens, so it doesn't, one of the kind of joking things is, how do you know a cryptographically relevant quantum computer is there? Well, that's when all Bitcoin are gone, or all your Bitcoins are stolen. Right, but we'll hope it doesn't come to that. So, yeah, definitely the organizations like IBM, who builds these things, probably thinks along these lines, right? Not going to throw out something that does it easily. And it's going to be expensive as hell, though.
And I think this also goes back to that point about prioritization and what is your high-value data, and focusing on knowing what cryptography you use, what the impact of that is, deciding where you need to put those protections in place now. Don't try and fix everything, but focus on that priority, because we may not know when it happens until afterwards.
Thank you very much.
Right. I think we're at time. If you have more questions, please find us near the stage. And if you're interested in starting more discussions around it, also please find us near the stage. All right, thank you, everyone.